Welcome, my name's Dewayne Hendricks, Tetherless Access. I usually hang out in Detroit. I moved there 4 years ago, but I'll get into that. I wanted to acknowledge that I've spoken to EE380 twice before. The first time was sometime during the 90s. I don't remember exactly when. I don't remember, I couldn't find my slide deck for then, but I remember it in my mind's eye. I remember the dinner I was taken to after the talk, so hey. But the last time I spoke to this colloquium was May 2000, okay? And the talk was networking Tonga from the ground up and the sky down, okay? So at the time I was doing this big project in the Kingdom of Tonga in the South Pacific. So 14 years, basically, have passed since I addressed this august body. So I've been basically known, I'm a serial entrepreneur and I've done a lot of things in my career, but I've been sort of tagged as the wireless guy, okay? So I wanted to sort of bring this up right at the front because I do a lot more than just wireless, okay? So, as you'll find out. So, native of Detroit. I left Detroit in 1970 to go to Southern Illinois University, Carbondale, to work with Bucky Fuller and what was new at the time, the World Game. So I met Fuller and worked with him in his design department there. While I was at SIU, the ARPANET was coming into play, and SIU had a connection to the ARPANET via the University of Illinois. So we had this TTY that was connected to U of I, and we could do this, play with this ARPANET thing. And at the time, I have to admit, I didn't know what the hell it was about, all right? But it was there, and it was free. I left SIU in '76 and came here to the Valley to work for Amdahl Corporation, okay? So that gets into, I've done a lot of other things. I came to Amdahl to be a VM 370 systems programmer, okay? I stopped working for other people in 1980, and since 1980, I've been doing my own companies, either as a founder, co-founder, CEO, VP, whatever was appropriate. I've done 6, one of which has gone public. That was Tetherless Access Limited, went public in '96 on NASDAQ, and disappeared 2 years after that. It was ahead of its time. But that was a wireless internet startup that I co-founded with a guy named Charlie Brown in 1990. So think about it, 1990, we were basically trying to raise money for doing metropolitan area wireless internet. Okay, needless to say, there wasn't a lot of scratch for that at the time. We didn't get funded until '94. We got $1.5 million from a hedge fund in San Francisco. Okay, so and away we went. So we deployed a lot of wireless networks in a lot of developing countries. That was our forte because, to be honest, there wasn't any action here in the United States. Where in developing countries, it was like, we need infrastructure, we want the internet, okay, and we want to do stuff. And so the money flowed. In '96, I was a member of a National Science Foundation funded project to bring the internet to Mongolia. And I bring this up because I think it's important because you don't bring the internet to a country for the first time that often. And NSF funded a satellite ground station which had the speed of 256 kilobits symmetric, okay? And my role was to distribute, this was the capital of Mongolia, Ulaanbaatar, and distribute from the satellite ground station all over the city and create a wireless MAN, okay? So the State Department was involved, and we were able to ship all our equipment over to Mongolia via the diplomatic pouch. So, and we staged our entry into Mongolia through China. So we ended up in Beijing. So I could go on, I could tell tales about that particular trip. Those of you who know Glenn Tenney of the Hackers Conference, Glenn and I were the team that went there and actually was in Mongolia. The PI for that project was Dave Hughes, known as the Cursor Cowboy. John?
How many diplomatic pouches does it take to carry over the whole dish antenna for your end of the satellite link?
Well, the way it works is that you just give them stuff at whatever the size, and then they figure out how to get it there, and they don't exactly tell you when it's going to get there. You just turn it over, and it appears.
My friend Tom sent the first email from the South Pole, and he has a photo with his dish. It'll fit in basically a case that you could put in an overhead bin. Because I know you, John, if you want to copy that picture,
No, that's fine.
I'll get Tom to get a photo to you.
Sorry about that.
No, it's not a problem. But one other aspect of this thing is that it was like planning safari to darkest Africa. And we had to, there was no Radio Shack you could go to. So we had to bring everything, we needed to do this. And that was a real challenge. And we had asked the locals to do a site survey. And when we got there, we found out that there were all these Russian concrete buildings surrounding the base station that were higher than the base station. Okay? And we thought that was it. It was time to go home. Well, we decided to do an experiment. Okay? So we decided to deploy the 900 megahertz data radios, spread spectrum data radios we were using. And it turned out that there was a quirk in the construction of these buildings so that they were transparent at 900 megahertz. Okay? So, yeah, so we were able to punch through with, a watt of power and cover what we needed to cover in the city. So this is an important lesson here, is that, experimentation works, and that never say die, well, all the other phrases you can think of, but try it, maybe it'll work. Okay, and it did. All right. As a result of all that, I got dubbed to be the broadband cowboy by Wired magazine in 2002. They did this profile. And, some of you Wired, they make stuff up, and it's like, how did I get to be the broadband cowboy? Because you see any boots, hat? No. Okay. But I think what they were trying to go for was this sort of doing things off the grid, or, not normal, being innovative and whatever. So, okay. So I want to call out two of my primary mentors in my career, Bucky Fuller and Paul Barron. Now, Bucky, I actually did a startup in Carbondale, and it was a communications startup and a communications networking startup. And Bucky was an investor, and he put money into it for about a year. Okay? It never went anywhere because it was another one of these ahead of its time things, but he was an investor, and he did that. And that's a little known aspect of Bucky. He'd do lectures, and then the money he got, he would do venture capital. Okay, and then Paul Barron. Paul was, I think, the epitome for serial entrepreneurs. You guys know Paul, Metrocom, Com21, all kinds of stuff. So Paul was a ham. I'm a ham radio operator. And that's how I met Paul, through that fellowship of amateur radio. So I moved back to Detroit in 2010, okay? Because you've all heard the Detroit stories. And as a native, I wanted to go back there and see what I could do to try to turn things around. And here it is a number of years later, and nope, there's nothing I can do. So I want to talk a little bit about the title, on the framing there. I have been working on a project with the Henry Ford Museum in Greenfield Village in Dearborn, Michigan, for a number of years now. And it's related to the Maker Faire and the whole maker movement. And I've been applying James Burke's connection methodology to taking the collection at the Henry Ford and sort of going and saying, look, this thing in the collection relates to this, which relates to that, and is connected to this and connected to that, and bring it into the current time with maker projects. Okay, so I have a site that's called We Are All Makers. So the idea is trying to show makers today that there are lessons from the past that can help them do a better job as to what they're doing. Okay, so for instance, one of the things at the Henry Ford is the Thomas Edison's Menlo Park Laboratory, which is where he did the first commercial lighting system. Not the first light bulb, but the first commercial lighting system, okay? And that's there reproduced, and there's a power plant there, DC power, that powers the streetlights. So, it was the first industrial laboratory in the United States, and you get a chance to see how that was put together, and the accounting functions, the publicity. It was an engine to do science or make money, okay, pure and simple. And so I've been able to take all that and give some talks and stuff about how that's done and how it relates to a lot of the maker projects where they don't look to, for instance, the money angle. So it's just sort of a short-term game kind of thing. Okay. But when I started to put together this talk, I basically looked to the 19th century and what happened there in terms of looking for early internet. And I'm working with a colleague and friend, Mike Leopold, at the Institute for the Future in Palo Alto. And we're working on a project which we started calling Plan B Internet, and we're now sort of calling it Second Curve Internet, and we'll probably end up calling it something else. But Mike came up with a framing and narrative that was, I think, much more powerful than me being stuck in the 19th century, in that he took it all the way back to Greek mythology, okay? And that, think about it, it's like the internet can be found back there, okay, at least some aspects of it. And I'll show you this because it's sort of fascinating, because I think it sort of speaks to, when you say this word, the internet, what does it mean? You know, okay. So, and what I've discovered is that little is really new when you look at it at a certain level, historically, okay? And I'll try to show that. And so let us begin. So as part of this connections work, I sort of have a set of first principles or premises. First comes the technology. As time passes, it becomes more accessible and affordable. Good enough is acceptable for most folks. More than we know is always happening under our radar screen. And finally, because one of my first loves is wireless, this thing wireless is like one of the technologies that we have that's sort of like magic. So I'm quoting Clarke's third law, which is any sufficiently advanced technology is indistinguishable from magic. We all use wireless in one form or another, but few of us know how it works. Even experts in the field don't really know how it works. And I can assure you of that, okay? But that's a talk for another day. But I'll get into the wireless angle because wireless can be used to build infrastructure, and that relates to where we might go with the internet. So now I'm going to go back to the 19th century. So prior to the 1830s, the fastest way you could communicate was by horse or the fastest wind-driven ship. Okay? That'll change in the 1830s with the invention and deployment of the telegraph. So all of a sudden, the world went from foot speed to light speed. Now, if you go back and look at the historical documents in that period, it affected society globally tremendously, okay? And since we don't go back and do that, we have no idea. But I've sort of done that, and there's a great book about that, and then by a guy named Tom Standage, which I'll have a slide in a second. But if you read some of the historical documents then, they sound like things that could have been written today. I have a bill from the House, 1854, where the startup company is petitioning the Congress to fund a transcontinental telegraph system that would be buried, not on poles, but buried. Okay? And if you read this proposal and how it's being evaluated in committee and all that stuff, because I got the whole bill and I want to put it up online so you can see it, but it's a fascinating document because you can read this thing and just say, what? This is 1854? You know? And you don't really get that until you see him talking about telegraph and how many words they can send per second. Okay, I mean, per minute, okay? And then you say, oh, that's a pretty slow physical layer, okay? But all the other politics and the funding and the, you know, it's all like today, okay? So, remember I said that when the technology comes out that it's not that accessible? Well, the gateway to the telegraph system were these guys. You go to a telegraph office, you give them some money, and they send a message. So I call out this book by Tom Standage, The Victorian Internet. It's a quick read, but it really gives you a sense of the parallels between what we're facing now and have faced and will face and what they went through in the 19th century. Now, the timeline was pretty long then because it took a long time to deploy the telegraph, you know. And then the reason that the startup that I mentioned didn't get their funding was this thing called the Civil War intervened. And everything, just that kind of stuff stopped dead, all right? But think about it. I mean, to bury a telegraph line all the way across the country, okay? And there were technical reasons why that was a better approach, like it was more resilient, you know, because they had seen what happened to, you know, with weather, okay? So think about it, if that had got funded, the first fiber system, all right? But it didn't. So after the Civil War, they laid the transcontinental cable to bring telegraphy across the Atlantic. And then later in the 19th century, this thing called the telephone came about. And I don't cover the telephone because I just want to stick with this telegraphy thing. But I do want to call it telephony to the extent that the telephone network, the telegraph network, was that you go to some place and you give them money and they send a message, okay? So that was the access metaphor, all right? Telephone, of course, got installed in your home, all right? So that was really different, all right? But I want to put that aside. So if we look at telegraphic networking, if you look at the access issues I covered, the infrastructure, well, you had a lot of different telegraph companies, okay? Independent, lots of them. But to send messages across the country or some distance, they had to interconnect their networks. So they developed a networking protocol suite, okay, to do internetworking, all right? And there were costs associated with that, all right? So all that got worked out. Our government got involved. And the thing is, we are really ignorant about how that process worked. Now, historians like Standage go back and look at it and they say, wow, you know, this is really like the kind of stuff we're hearing in the news today about the internet and peering and yada, 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 okay? Lessons learned. So, let's go to Marconi. Things change. So remember my first principle, as the technology evolves, it becomes more accessible and more affordable, all right? So with telegraphy and the telephone, you have wires, physical wires that you lay, and there's a cost associated with that. Wireless changed the game, okay? Because now you could have path between point A and point B that was completely arbitrary, and different business models developed. So from the time Marconi sent the first signal across the Atlantic in 1901, he had started, there were commercial wireless services in 1903. So what you're seeing is a compressed timeline, okay, from what you saw with telegraphy over the span of the 19th century. But here's the deal. If you want to send a message over wireless, you still had to go to this office. Now, you might be able to do it from a hotel where you fill out a form and they take it to the office, but there was somebody always in the way. You didn't have access to the network, you as an individual. And guess what? There was no transition in that, this stuff wireless propagated at light speed, telegraphy, so it was light speed to light speed. So there wasn't any real major change to the system, except in some very subtle ways, like the telephone, a network access device in your home. That changed things, okay? But as we moved into broadcasting, after the Titanic sank, okay, and now you could go to a store and buy a network access device called a radio, okay? You put it in your home, and now you have access to this networking thing. So telephone's two-way, broadcasting isn't. And the general public didn't have access to two-way transmission until, fairly recently, like Wi-Fi, unlicensed spectrum, unlicensed devices. That's when we got parity with the telephone system using wireless technologies. That's very important. So, but the same thing, again, you had a lot of independent companies doing wireless. They had to have a network protocol suite, and they did internetworking, okay? Because wireless, only with a certain distance. If you look at the Titanic disaster and how that was handled, there were a lot of ships that relayed messages, and so there was a protocol, okay? Packet hopping. So commercial internet comes in about 95. I'm using 95, and we could quibble about 4, plus or minus 1. But this was a big difference for us because we went from what I call light speed to warp speed, okay? Faster than light. And I say that because of the network effect. Metcalfe's law, Reid's law, okay? Mesh. So you had a different kind of architecture for this internetworking thingy than we had with other technologies in the past. So, we all know about this slide. I mean, we could talk about it at length, but let me move to here, the internet. So to coin a phrase from The Princess Bride, you keep using that word. I don't think it means what you think it means. And that is sort of the crux of where we are today, in that if you look at my background, I've been doing internetworking for a long time in a lot of different places, okay? And I've been able to use the end-to-end principle to do peer-to-peer, to do mesh networking, all that stuff because I was using wireless so I could create infrastructure like this. And there are a lot of other people like me. Right now in the United States, there's about 4,000 wireless ISPs, okay? But you would know it because of what, well, a lot of things, the media. But this internet thing, remember I mentioned the Icarus thing in mythology. There's a famous line from the movie The Man Who Shot Liberty Valance from the end. When the legend becomes the truth, print the legend. Okay. So a corollary would be when the myth becomes the truth, print the myth. Okay? And that's sort of what we got. Okay? This internet has become this mythical thing that has different meanings to whoever, you know. Politicians have a meaning, like it's the tubes. We could have fun with that all day. Let me tell you what it means to me, early on when I was trying to do a startup and make money, okay? The internet to me was independently owned and operated networks that communicate with each other using this common protocol suite, this TCP/IP protocol suite, okay? So we run our networks, we spend the money to keep the infrastructure up and running, and we agree to peer, and that's how we move packets. That was what the internet has been for me for a long time, okay? That's not what the internet is for a lot of people today, okay? All right? If you go back a few years ago to the FCC when Obama came in and brought in Janikowski, and they started the National Broadband Plan, okay? If you read that National Broadband Plan, I think the internet is maybe mentioned once, but it's broadband. It's broadband access. But access to what and why? That's not really covered. So that's a glaring omission, but it's also symptomatic of the problem we have today, okay? Because you got this net neutrality thing, and okay, so here. I subscribe to the Rachel Maddow Show's newsletter, okay? So for the last week, there's been this ad from the Motley Crue embedded in her newsletter, which basically says, rest in peace, internet, 1969 to 2014, okay? It's been running every day for about a week. And so when I was putting this talk together, I looked at that and says, wow, there's something going on here, okay? And then yesterday, I saw an article in a pretty prominent online tech pub that was titled, "The Internet is Fucked." And it used a lot of harsh language, but that was a subject line, and it was designed to get your attention, obviously, okay? But it went down all the different things that we sort of have heard about, net neutrality, the post-Snowden world we're in, privacy, all that stuff. It was a pretty long article, hit all the points, and seemed to adopt the position that, hey, we can fix this, okay? So, I told you what my idea of what the internet, it's an operational definition for me. I can go out and build a network using wireless. I can connect it to other wireless networks. Like I said, there's 4,000 wireless ISPs. There are a number of them operating in the Bay Area. I had a friend ask me today, gee, how would I get the internet where I am in Cupertino? And I said, well, besides going to Comcast. I said, well, there's probably a wireless ISP that covers you. But most of the wireless ISPs have gotten out of the residential access market because there's no money there. 14 years ago, I was a wireless ISP trying to slug it out here in the Bay Area. I had a mountaintop site on Mount Allison in Milpitas. And I was broadcasting there. In fact, in 98, when I was working for Com21, I had a system up there that used the cable modem system that Com21 had created. I turned it into a wireless cable system. And I had coverage from Los Gatos all the way up to San Mateo. Okay. And at the time, I think our modems did 15 down and 2 up. Okay. So this is 98, 99. And what we did is we just sprinkled them around to different people in the Bay Area, our friends, and said, hey, use this thing, get your high-speed connection to the internet, and all we require you to do is talk to people about it, okay? So what I want to do with this talk and leave you with is sort of showing you what the realm of possibilities are. Because you've all been sort of in this world where there's a lot of constraints there. You sort of have forgotten what's possible, okay? Because you don't put down wires, you wait for people to put down wires because of all the various issues associated with it. Wireless is different. Now, there are problems with wireless, but this is not the place to go into that. And in fact, I'm not here to go into any particular protocol, okay? Because there are places to do that. What I want to try to do here is to get you to remember, if you've forgotten or learn now, what the internet is. The internet is an abstract noun, okay? It's not a bunch of fiber or access methods or whatever. It's what you make of it. And that the founding fathers, the internet graybeards, created this protocol suite which allows you to enables conversations, okay? And you can use it to set up any kind of conversation you want, pretty much, okay? It's not perfect, but to use a phrase from the IETF, we believe in rough consensus and running code, all right? So, now, one of my close friends, David P. Reid, was one of the co-developers of the end-to-end principle. And he's been fighting this battle for a while now to try to get people to remember what the internet's about. So last September, he wrote this nice blog post, which is titled "What the Internet Is and Should Continue to Be." And he sets forth the fundamental, what I think principles or an operational definition of what that is. So I encourage you to go and seek out this blog post paper by David. It's very short and very succinct, okay? But I think it goes a long way to helping us remember what the internet was and could be. Now, I want to talk about this project I'm working with at the Institute is we're sort of calling the second curve internet, in that we've got this first curve, and then you can apply this sort of methodology back to the 19th century, and you look at how things progress over time. There's some fascinating aspects to this, but anyway, so we're looking at things that are coming on early that may allow this second curve internet to bloom. So remember, I said that in my first principles that there's a lot of stuff going on under the radar screen that you're not aware of. So I think we can all sort of relate to that. I certainly can. But because, things like all of a sudden, like there's this startup that comes out of nowhere and is worth $2 billion, and they, you hear this and they're doing something, and whatever it is worth $2 billion, okay? But you could look at where we are with the internet. Now, again, the article, "The Internet is fucked," or "The internet basically is going to die this year and be set, rest in peace." So if you believe that, well, what does that mean? What are we going to do? Okay, because Comcast is still going to be there, Time Warner's still going to be there, and they're internet access providers, or they're access providers to something, a silo of something, walled garden, whatever you want. But it's like when I travel. Like starting about 2000, okay? You go to a hotel, you get internet access, and I had all these peer-to-peer apps on my laptop, okay? And so I get access to the internet or something, and I found a lot of my apps didn't work because certain TCP ports were blocked or IP ports were blocked. UDP ports were blocked, okay? And I just say, okay, that's it for that right now until I get back home. So I saw this, a long time ago. And then, more recently, people started yelling and screaming about Comcast is blocking BitTorrent or whatever. And I was like, well, wake up. Net neutrality left the barn, took a ship and went to Europe, 10 years ago, okay? And you're worrying about it now? Wake up. But to be fair, people weren't running the kind of apps until more recently, like a BitTorrent, okay, which attempts to do peer-to-peer stuff. Okay. There are two projects I want to showcase in this part of the talk. The Free Network Foundation, Eben Moglen, Columbia University. Several years back, Eben and Richard Stallman. Now, Stallman, we could talk about Stallman but I'll just talk about Eben Moglen and leave it at that, all right? So Eben's rational and lucid and responsible. So, and bays quite often. Eben looked at where things were going and he said, look, there's this internetworking thing, and we've got to get internet working back to the grassroots. So we need to basically put servers in people's hands. People need to run servers, okay? And then people went to Eben and says, well, wait a minute. You need to be a net group. You're talking about running BGP at the community level, and it's like have grandma run a BGP router. Okay, that's not going to work. How's that going to work? So, because that's what internet working is. Like if you're part of, the network operators group, it's like you got to run BGP. That's, put this badge on. I run BGP. Okay, IP. That's your badge of entry. So, you can go to the Free Networking Foundation's website, but what I want to hit, or what I hope are the salient points, in that they put together a development team to develop the code, open source, open hardware, necessary to make this vision a reality. Now, it's a hard piece of work, because how do you take the TCP protocol suite and sort of simplify it or put something on top of it or around it to make it accessible to grandma? Okay. So, Eben calls it innovation under austerity. Several years ago, he gave a talk to David Eisenberg's Freedom to Connect conference. It's up on YouTube in the 2012 Freedom to Connect YouTube channel. It's called Innovation Under Austerity. It's about 90 minutes. And those of us who were there, when he was done, he just stood up and just did this talk. No notes, just extemporaneously gave this talk. And when he was done, everybody jumped up and gave him like a 5-minute standing ovation. Doc Searles said it was akin to Martin Luther King's I Have a Dream speech. And I would agree with that, okay, in terms of the relevancy to this problem of what is the internet and how do we solve the problems that are sort of getting it off track. Innovation under austerity, okay? Because you're not going to get money, you're not going to get funding to try to do this. And so Eben has a plan, and that plan is outlined in this talk. Now, New American Foundation and the Beltway. They have a program called the Open Technology Institute, which is run by Sasha Meinrath, okay? And they've been working for several years on something called the Commotion Project. They got money from the State Department, okay, to fund this internetworking system that you could plop down in Egypt amidst all the turmoil and create a number of independently operated networks that would peer with each other and exchange and have conversations, okay? That would deal with privacy concerns, encryption, all that stuff, all right? So that your garden variety agitator could set up a network. Now, there was some talk in certain circles about, well, this is money from the State Department, so where's the back door? I mean, come on, there has to be a back door. So, you know. But this, what Commotion does, it uses wireless technology to set up infrastructure, but it does something that's sort of different than what we've seen before, in that it uses the cellular system, okay? So inside this box is a open BTS base station, okay? So it can do GSM where appropriate. So they're basically modules you can plug and play to get the kinds of physical layer stuff you need to set up the network you want. Commotion.
How's it funded?
Well, the State Department's still funding it, okay? Now, even post-Snowden, okay, because a lot of what this is about is improving your OPSEC, operational security, so that the NSA can't spy on you, okay? How many of you use PGP here? Oh,
Use or have you used?
okay.
Yes. So roughly half the people in the world are in this room.
I was at a conference last September in Woods Hole, Massachusetts, and it was sort of a, I wouldn't say undisclosed location, but it was, there were 50 people there who a lot of you would know, and we were sort of there to discuss the future of the net. A lot of internet graybeards were there at this event. So, and Bruce Schneier, the security expert, was there. And he was fresh from seeing all the Snowden documents. So what we had a chance to see was him preparing stories to be printed in The Guardian, but also talking at great length about what was going on with the Snowden documents and all that stuff. And one of the discussions we had with the people there was that we all needed to improve our OPSEC, because what Bruce said was that the intelligence agencies, if you encrypt, then basically you're okay with a lot of the bulk surveillance, okay? But for targeted surveillance, when they decide to go after you, they're going to get you, okay? So I found out that Bruce at the time, and he was pretty open and honest about this, when he started to try to get access to the Snowden document, his OPSEC wasn't up to snuff, okay? And they said, no, 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 you need to improve, okay? And I found out that Bruce wasn't using PGP, okay? And if you go to the public key server and pull down Bruce Schneier's public key, you'll see that it was first created in September of last year, okay? Now, I mentioned this not to dig at Bruce, but just to show you that, hey, you know, even a security expert doesn't necessarily get it right all the time, okay? Now, what we found, and we had a PGP key signing party, so a lot of people there, if you scan for keys that are created on a particular date on the key server, you'll find a lot of interesting people that you might know, okay? And what we found is that even to get PGP installed on various people's machines was an ordeal. And some of the people basically said, this is too complicated, all right? Too complicated. So they wanted something simpler. So somebody said, well, there's off the record, you know, for chat. You could do that, okay? Anyway, that was a big takeaway for me about this whole, so if you got all these net graybeards and other people, and they're saying that to improve their OPSEC was just too much of an ordeal, okay? You can see the problem we have going forward with this internet thing, okay? So unless somebody like Commotion or the Free Network Foundation comes up with this in a box, but there is no technical solution, because what we found, and what Schneier will tell you if you read his stuff, is that when you start doing peer-to-peer, you've got to have a trust model in place. You have to trust who you peer with. And how do you establish that trust? Okay? That's a big problem. And we don't have any real good solutions now. And just to give you an example of after this conference, because I signed Bruce Schneier's key, he signed my key, and we were right in the same room, and we could check our IDs and all that stuff. That's what you're supposed to do at a key signing party to authenticate. I get a call from a friend of mine, Phil Karn, who's another net guru, and Phil says, I see that Schneier signed your key. Maybe I ought to sign your key. So let's schedule a, chat on the phone where we'll authenticate. Okay? And we did. So, but you see, how does that scale? It doesn't. But how do you generate trust? Okay, but look at what happened there. Schneier signed my key. Karn says, oh, okay, I'll sign your key. So what happens is, depending, you look at people who signed their key, their public key. And then you can make a decision as to whether or not you trust them. Okay, and how much trust you want to put into that relationship. It's a start. It's a start.
It's only 6 steps. Before the messages that arrived, they didn't count the messages that didn't arrive.
Well, the question you ask about, when you ask the people how many people have used PGP, that's not the question that I ask people. I ask them, what percentage of your email have you encrypted PGP? And I generally found this tends to be less than 10%. Now, it turns out the first person that I exchanged my PGP key with was, let's say, a friend of mine at one of these intelligence agencies. And we were both kind of experimenting. But since that point in time, we practically have never, and this is a guy who exists in the real serious crypto world as well, too. But I've never found anybody to encrypt more than 10% of their email.
Okay, I have a story that relates to this, all right? I have this list called Dewayne Net, and it's sort of like Dave Farber's IP list, and we sort of bounce stuff between our two lists. And so I put out a sort of how-to about how to do encryption, and then Farber put it out on his list. And then I got contacted by this woman who was inside the intelligence community, okay? She had a security clearance, and she was an attorney, and she basically went out and got a public key, and she sent me an encrypted message and wanted to know if I got it okay, and I said yes, okay? Then I asked her, do you know what you just did? Okay? And because, what the current rules at the NSA, when you encrypt, that sets a flag, and that message is saved forever, okay? And you're in the security community, so, I don't know what my standing is with that community, but, I associate with people like Dave Farber, who's on the board of EFF, okay? And I'll have another story about that in a second. So she came back to me and said, well, I'm just a little person. I don't think I'll, And I said, really? And we terminated. I mean, it was like, okay, that was the last communique I had with her. But it was that sense of naivete. It's like, hey, I got nothing to hide, and, right? Last June, Dave was out here for an EFF board meeting, and we got together in San Francisco. And we were on Market Street, sitting in a coffee shop, just sitting there, taking in the sights. And we started talking about this whole thing, because the Snowden stuff has started to come out, and we're like, I said, Dave, we're sitting here generating all this metadata. And you run your list, and I run my list, and now they got all this metadata with us, sitting right next to each other, okay? And all this is being recorded, And when you really parse all that, and it's like, you just have to laugh, because it's like, what else are you going to do? Okay, now, I want to mention something that I mentioned at this workshop in September at this undisclosed location. There's a television show, and I know a lot of you don't watch television, but it's on CBS. It's called Person of Interest. Okay? Now, I didn't know person of interest from anything. And so I have this close friend who's retired ex-naval intelligence, okay? He lives in Southern California. So he calls me up and says, Dewayne, have you seen Person of Interest? And I said, no, why are you telling me to watch this? You know, because he doesn't watch a lot of television. And he says, you need to watch this show. And I said, oh, okay, you know. So then I was in Detroit at the time, and then I came here to Fremont. I'm staying with some people there. And one of the first things they said after I arrived, impromptu, was, have you seen Person of Interest? Okay, now I was like, the ears were perked up, and okay, no, okay. So I went and got the first season and blitzed it. And then I called my friend back down in Southern California, Yak Spook, and said, okay, I understand. This show is done by J.J. Abrams, Fringe, Lost. This is his version of Star Trek in terms of trying to use medium to tell a story, a morality tale, like Roddenberry used to do, okay? Because buried in this show, because this is a top 10 show, and each one of the episodes of this show costs $2.5 million. A season is 22 episodes. There's a lot of money that goes into this show. It's well written, it's multi-layered, okay? But basically, this guy named Harold Finch has developed something called the machine, which is given to the government. And it's basically this AI that's connected to all this infrastructure that we got, cameras, everything, okay? And it gives the government threat information. But there's a back door that was put in by Harold's partner that gives him Social Security numbers of threats that are not threats to national security. So Finch has put together a team to go after and try to determine whether or not those people are a threat or they need to be helped, and hence person of interest. Now, when you watch the show, they have camera views at the machine. You see what the machine's seeing. And what the machine does is he draws a rectangle around people, and it has different colors that indicates their threat level, okay? Now, there's a lot of Easter eggs in this show, so that if you're just a casual viewer, you'll see white rectangles and yellow rectangles. But there are two other kinds of rectangles. Yes, Root has her own rectangle, okay? And a threat that doesn't know about the machine has its own rectangle, okay? So, for instance, it'll be white with red dots, okay? So if you don't know about the existence of the machine, you have a white rectangle. If you know about the machine, it's yellow, okay? Now, the machine, now this is, you could call it science fiction, but the thing is, what my friend was telling me from naval intelligence was that, hey, you know what? This thing is pretty much almost there, okay? And there's the technology that puts those rectangles around people exists, okay, today. You can go buy it. So, to me, it's been fascinating that a top 10 show with this kind of subject matter, is playing in America and people are lapping it up, okay? So it's like, they must be getting some aspect of this show. Now, recently, you know, I saw, you have to conclude watching this show that our intelligence agencies, they have to build the machine. They just have to. They're on a trajectory to build this machine. They're going to go through hell and high water to build the machine. And then recently I saw something where IBM is put $1 billion forming this Watson division. And IBM does a lot of defense work. And then I said, aha! Watson plus equals the machine. Okay. They're going to do it if they haven't done already. I mean, okay? So watch that show because like Star Trek, it speaks to you on many levels, okay? And Also, I've used it to get people, like, for instance, Dan Gilmore, okay? I went to Dan, I said, at this meeting, and I said, Dan, you got to watch the show. And Dan, to his credit, got the whole first season on Netflix, watched it all, and he came back to me and says, yep, okay? So I can now point other people to this, and if they invest the time to watch at least the first season, they can get it. So John, you got it. I mean,
That's great.
all right.
If anybody remembers a movie from many years ago called Enemy of the State, it's very much the same kind of behind-the-scenes observation of network, citywide surveillance systems and so forth.
Yeah.
So is Madison Avenue going to build it before the spooks?
I think they're working on it. I think they have aspects of it. Okay.
Go to London or go to England. I mean, some people would say England has it already, but they don't.
But here's the thing. There's nothing from stopping you to build your own machine, too. Okay? You know?
People that are already doing plates. What I do with faces.
Yeah.
Face recognition is very tough. It's not nearly as good as people say.
Yeah, right.
That's what they want you to think.
I know our
So-
Another example is license plate readers. It turns out that the repo men nationally are collaborating to build the license plate tracking database. Story out today in Slashdot, I think.
They now claim they're backing away from that.
No, this is
we
not the
can't-
government doing it. This is the repo man doing
Oh,
it.
the repo man.
Private.
Well, the government claims they're backing away.
Well, who cares about the government? They can,
I
they
care.
can, they can buy the data from the repo men. It's $25 to track a license plate wherever they've seen it.
But see, I'd like to go back a bit and quibble.
Sure.
You said that light-speed communication began rather late. A crude form of it actually goes back thousands of years. It was called smoke signals. Now, that was a limited form of communication, to be sure.
No, but you're into what I was saying, because I said, go back to Greek mythology, okay? And then look for parallels to what, okay?
Fair enough.
Right?
Um,
And that's great. That's a good one.
Like most historical overviews, you skipped over the first computer network, which was in the 1950s. It was the SAGE air defense system, which was a total fraud. I can say that with authority because I was one of the fraudsters. It never worked as an air defense system, never could have worked, but it was kept going for 25 years for the immense profitability of a number of contractors. And they did that by classifying its deficiencies, secret. And exactly the same thing is going on today with other contractors, like the ballistic missile systems. And they're being deployed, they don't work, never could work. And you know, this stuff goes on and on.
Okay.
Well, a couple of other things.
Well, I have a couple more slides, and then I'll open for questions. Is
Fair
that fair? This is the last slide before I open for questions. All right. So, the darknet. Now, again, this is a loaded term. I know that. So, there's more going on there than you're aware. So, let me talk about my experience with the darknet. Back about 2000, I was hired by EDUCAUSE. EDUCAUSE is a lobbying organization for colleges and universities. And there was this whole peer-to-peer thing going on in the file sharing in the colleges and universities. They wanted to get a handle on it. They wanted to find out about the darknet. So they asked me to go out and explore it and come back and give them a report. So I joined a number of darknet communities just to get my foot in the door and figure out what was going on. So it was very interesting because what I found was there are these sort of like gated communities out there, and they basically use the internet for tunneling, and that they have tunneling protocols, okay? So they just use the internet to move their packets around. And And they're not all about sharing files and stuff. There's a lot of stuff going on in the darknet. So I was able to get into several gated communities, and what I found was this thing going on, which is this all for one and one for all protocol. Okay, people bring their machines, their bandwidth, storage to the party, and nobody pays anybody for anything. Things just happen. There's agreements cut, okay, and content is shared, whatever. It's a pretty dynamic system. For instance, I've been part of a system that's sort of based in the UK that you can have, it has essentially accessible online pretty much everything that's aired on radio or television in the UK since about the 50s. Think about that. A library that's pretty big that, rivals the BBC, but it's all done by people and nobody's paying for it, nobody's exchanging, and everybody's bringing something to the table. To me, this is remarkable. And that's what I went back and told EDUCAUSE. And I found that they didn't really want to hear it because it was a message that they wanted to float around the Beltway. Okay? So what's going on in the darknet is what I think exemplifies the internet, which is innovation without permission, asking permission. Okay? You just do it. And you're seeing new protocols and stuff being developed because there's this sort of arms race with law enforcement. Okay? So you've heard all about the Pirate Bay. Well, the Pirate Bay's basically now developed technology so that you can't find it anymore. Okay? But it's out there. Okay? And so it's been a forcing function that I think we sort of need with other second curve internet efforts. Okay? So that concludes my remarks, and now I open the floor for questions.
Okay, I'll make a couple more remarks.
Go ahead.
I claim that there are something like 8 key inventions that made the modern internet possible. And most of them were made altruistically. No patents, completely open. The people who made those inventions helped others develop them further. And had that not happened, but the internet that we have today would not exist. What we would have is a set of proprietary networks that don't function at all well, don't talk to each other, and it would be a real mess. Unfortunately, of course, both commercial entities and governments are trying to get it under their control. And if the commercial entities succeed in destroying the openness of the internet, as is currently happening, the whole thing's going to go down the tubes. So we can only hope that the technology can keep ahead of the attempts at getting it under control. Well, that's a personal opinion. Just for what it's worth, in addition to helping create the first computer network, I helped design the ARPANET. And I noticed you used the start date of 1969, which is what people claim was the start of the ARPANET. It actually did not work then. It actually began working around 1971. And then the next step was, of course, the internet protocols, which incidentally were developed here at Stanford by Vince Cerf. I helped him set up that project in 1973, I think it was. And
Sir, what's your name?
Les Ernest. I'm finally getting around to writing up some of this history. I haven't published it yet.
I know who you are.
Of
course, 69 was the first piece of what looked like a communication.
Well,
UCLA
there was an electrical connection,
Yeah,
yes.
and that was not a fraud.
But I don't call that a network.
No, that was not a network. That was a point-to-point communication.
Yeah,
But it was 69.
very much like telegraph.
Yeah.
Well, anyway,
Yeah, Les, actually, just to let you know, I mean, he actually had some of this stuff, and he deliberately skipped over the 69 to 95 period. He had a slide. You missed that, because I saw when you walked in. So. No, it's okay. I mean, I've done it too.
There was an oblique reference to ESL too.
Yeah, yeah.
oh, I missed that.
ESL, the labs and the trailers, where the internet was actually developed, the buildings that have been torn down, replaced, and those buildings have been torn down, which is why the plaque is now in a building that had nothing to do with internet.
Right.
Not anything.
Well, but one point I hope will sink in that altruistic inventions and open software played a major role in all of this. And it would not be what it is today if it had all been developed under the capitalistic system.
I think it's interesting that you pointed out the person of interest. A lot of it's based around the idea that these systems have backdoors in them. This is something, there's another reference for that, which is William Gibson's Spook Country, which is pointing out that if you build the kind of surveillance system that there is in London, there has to be a way for the spooks to avoid getting caught by it.
Good point.
So all their rectangles get erased.
Read the book,
What was the name of the book?
Spook Country by William Gibson.
Any other questions?
Yes. If you were appointed chairman of the FCC, what would be your priority?
You were.
On the FCC. To wipe in.
I served on an advisory group that started in '98 called the Technological Advisory Council. I was on it for 8 years. So I played the great game, okay, to little effect. I would say, to be fair, during the Clinton administration, for 2 years, we really did stuff. And I was really proud of being on the TAC. And then the Bush administration came in, and then things changed, okay? Several years ago, I was actually asked to interview for Dave Farber used to be the chief technologist, so he was instrumental in getting me put up to be, recommended to be the chief technologist, okay, under Janikowski.
Yeah, actually, it wasn't just Bush. It was also when Ronald Reagan came in the office, too, because the guys at Park had Xerox machines at the White House. And then when the Republicans came in, they said, what's this stuff? What are you going to do with it? And they had no concept.
So I would say the technical people put me up as the lead candidate for that position. And then I had to go interview with Janikowski's staff on the 8th floor there, and I didn't pass muster because I told the truth, as I see it. So I didn't get the job. So, but to answer your question, if I was, whatchamacallit, the guy that's Wheeler, I would start by reorganizing the FCC from the current bureau system. It's inappropriate for the 21st century where we are now, okay? You know, it's a relic of the past, and if I did that, it would show the Beltway, I meant business, about trying to move us into a more measured future, okay? And I would also elevate the technical part of the commission. Office of Engineering and Technology is just that. It's an office. So it's at a lower pecking layer than the bureaus, okay? And that's always been the case. The other thing is that the FCC used to have a tremendous field organization. Offices all over the country, staffed by, there was a guy named Phil Kane here that was chief engineer in the San Francisco office, who was both an engineer and an attorney, okay? And Reed Hunt, under the Clinton administration, dismantled that entire organization for political reasons, because Reed didn't want knowledgeable people out there second-guessing him and saying, wait a minute, you can't do that. So he got rid of them, lock, stock, and barrel. And at that point, the FCC lost its institutional memory, and it has never been the same since. Okay. Paul Barron and I testified at a en banc hearing on spectrum policy about the time that happened. Okay. And after we testified, Paul turned to me and said, "Look, I've been doing this for years, and I'm done." Okay. I mean, nothing's going to change here. And true to his word, he was done. He never had delved into FCC policy anymore after that. He just went out and did startups and stuff, and did stuff that he could do real things with. I, on the other hand, kept doing that spectrum policy stuff and whatever, and playing the great game until Martin was chairman. And I gave a talk here in the Valley, and I started out by saying, FCC Chairman Martin is a waste of space. Unfortunately, there was a reporter from Communications Daily in the audience. Communications Daily is read by everybody in the Beltway. So a couple days later, headline, FCC TAC member calls Chairman Martin a waste of space. The next week, the TAC was disbanded. This true story. Okay, it was disbanded. He shut it down. So I am credited with getting the TAC shut down. I was surprised why I was offered this chief technologist job. Okay, but I think there's a story there. I'm getting time, but if you tell the truth, that means something, even in the Beltway. Okay. And that people will rally around you and support you, okay, if you have the courage to go out and speak truth. That's what I learned from that experience. Okay.
Some people.
Well,
You've got lobbyists and congressmen,
well,
they're all on the take, so what the hell?
but some people.
Yeah, some
And
people.
revolutions start with a small number of people.
That's us, you're
Yeah.
talking to the community here.
So I would say in closing, here in my last minute or so, guys, please improve your OPSEC, okay? Come on. You know how to do it, and teach other people to do it, okay? Yes?
I want to touch on one thing that you assumed, but why does Grandma want to run a server?
She doesn't.
And Dave Weiner actually had the startings of an argument. He thought everybody should be running hundreds of servers. And then it turned into blogging, but ignoring that, why does Grandma want to run a server?
She wants to outsource everything.
And she has, it's called Facebook.
That's right.
Yeah, well, as you know, that comes with pros and cons. Okay, yeah.
Facebook. On your show, Person of Interest, at some point one of the people's comments on how hard it was to get this private information on people, all the things that they were thinking and so forth, because of legal issues. And Mr. Finch says, yes, that's why we invented social media.
Yeah.